Hello, how are you? I hope that you're doing very well today. We're here to speak about Lastpass, password managers, and just take a look how they work and how can we take advantage of them. Yep, here it is. So, like in every talk, we're gonna present ourselves at the very beginning. Here's Martin Vigo, he's here with me. Go for it.
Martin Vigo, thank you. I'm a product security engineer at Salesforce, and this is a picture of me. Anyone can guess which computer this is? 25 years ago, that's the hint I'm gonna give you. An Amstrad CPC, 6128, really cool video games.
You're too old.
Yes. Okay.
And that's me. I don't have any computer there, but I'm Alberto. I work at Salesforce too. We do like all-day research. We just started a team, kind of Project Zero. But so yeah, definitely we do very cool things at Salesforce. If anyone wants to join us, wants more information, we're always hiring. So just come to me and speak with me, and we can share a rum and coke and some information. And yeah, this is like Lastpass. This is going to be our target today. We want to tell you a little bit why we started like taking a look at Lastpass. I used to work in the red team at Salesforce, and we were seeing in a lot of machines that we compromised that there was like information, there was a Lastpass like file, Lastpass, basically Lastpass files in the systems, and we really wanted to get all the information from the password manager. Like we have to take notice that normally when you're doing a red team exercise, you don't have a lot of time when you are in a compromised machine. You just have some minutes, you have a specific time, and every time you spend in a compromised machine is one more minute, one more time that actually detection have to catch you. So it's very important that we get into a machine, we need to be fast as possible, to recollect all the information, recollect credentials, and move on. So that's something that we had in mind. And actually, I came to Martin because we have like 10% of our time to do research at Salesforce. We say, hey, Martin, let's take a look at this because I think it's super interesting from a post-exploitation view. And so we got a couple of gin and tonics, and we started looking at it. And this is what we saw. Like Lastpass is one of the most popular password managers that we can see out there. They have what they call the Enterprise Edition. So that's very interesting from an attacker perspective because you know that it's going to be used in large corporations, great target. And the interesting thing here is that Lastpass not only stores passwords, they store SSH keys, they store credit cards, social security numbers, private nodes. I've seen PGP keys in Lastpass. That's great. So that's how everything started. So here we have the agenda, what we're going to treat, what we are going to speak about, and the different like approaches that we're going to get. One of them, the first one, is going to be the plugin side, the client side. The second one we're going to speak about is about what Lastpass has. What's the information that they collect? Do they have access to our passwords? And at the end of the talk, we will change our point of view to like an outsider, not being Lastpass, not being in the client, just being like someone who is out of those two different environments. So let's start like speaking about what Lastpass claims. What do they say that they do, they have, or they are? They have like, among other claims, they have 5 that we think that are very important. The first one is that they use local and secure encryption. Second one is that they securely encrypt the keys that are used to encrypt and decrypt your vault, where your passwords are. Third one is that they use secure storage in the client side. Okay? The fourth, very important thing, is that the creds are wiped from memory. So those memory-based attacks are not going to be useful in this case. And last but not least, Lastpass has no access to your data. This is very important. I don't know if you trust third-party applications. I'm not a trusty guy, so I'm not going to give my passwords to anybody. They're going to remind me my computer, or if I send my passwords to somebody else, I will send it encrypted, and I will never give them the key to decrypt that vault, to decrypt the passwords. So we will speak about that. So to prove all those claims that Lastpass have, we started with a script. We wrote a script that basically, by the way, we are from Spain. That's why our accent is so weird, broken English. Come on, man. You know, I'm gonna tell you something. This is not prepared, but like he has a girlfriend, and yeah, you do. You're in Amsterdam, but you still have a girlfriend. So she always says, Martin, if you lose your accent, your Spanish accent, I will definitely leave you. That's completely true. And she always say, like every night, like every Saturday or Sunday we go out for some drinks, she said the same. Anyway, let's move back. So yeah, like to verify what those claims that Lastpass said, we wrote this script that basically just inject like one line after every function in the code, in the JavaScript code. It's a minimized JavaScript code what they used, and it gave us the chronological order from like every function that was called, and not only that, but the parameters that were like passed to every function that was called. So basically, we just like run this script, inject those like lines to give us the instrumentation. And we were able to see, like, okay, when we log in, these are the functions that are being called. So that like helped us to understand all those claims. So as I said, the first claim is that they use local and secure encryption. And they indeed do that. They use AES 256 to encrypt your credentials. The thing is that they use CBC and ECB mode. As you may know, ECB is not the best thing, the best practice. They use kind of a custom implementation, but it's okay. And then to encrypt your key, to decrypt your vault where all your passwords are, they use PBKDF2. They were using 500 rounds, now they're using 5,000 rounds by default. You can modify that value, but it's actually not very important that you modify it because you can do an unauthorized query to Lastpass. Just send in your username and it will tell you, okay, this user has this many rounds. Okay? It's just like something interesting to say. They use secure encryption keys. They use, they secure encryption the keys. So they use PBKDF2 with the number of iterations, and they use the username as a salt. Okay, they're restricted to 32 bytes, the output. They use secure storage. I mean, depending as you see it, they secure supposedly storage the credentials in the client side. It depends if you're using the plugin version or the binary version. If you're using the plugin version, they use SQLite files or that are unencrypted and that are not root needed. They use our SQLite databases of files, just files, depending on the browser. Firefox, for example, they use files all the time. And there's a binary version that they use as like platform-specific secure storage. If you use Mac, it's kind of interesting because they use the keychain to store this information. So that's more interesting. In the Windows version, they just use the secure API, Crypt and Protect and Crypt Protect and Crypt and Protect API. So it's not very useful. The other claim that we saw is that they wiped the credentials from memory. So as soon as you introduce your master password, okay, the master password is the one who is used to log in against Lastpass after doing applying some algorithms. But this is basically the code that they're using. They are setting the variable D and C password to a bunch of X. They are doing that in JavaScript. So supposedly the variables with your password will be like overridden. Will be great. The thing is that we saw that the vault decryption key resides always in memory. And you will say, okay, that's normal. You need to decrypt every time that you're gonna like use a specific password for a specific site, you need to decrypt it. Obviously, Alberto, the decryption key needs to be in memory. It needs to be used. But here the thing is that they decrypt the whole vault with all your password at the beginning. So in memory, we don't only have the decryption key for the vault, where all the passwords are encrypted, but we have the password in clear text. That makes no sense. You can pick up one out of two, but not like both things. If you don't want to decrypt your passwords at the beginning and have it in memory, perfect. You need to have the decryption key in memory. But if you decrypt everything at the beginning, why do you need the decryption key anymore? Okay? And the last one, the last claim, is that Lastpass has no access to your data. And that's actually true. They don't have access to your unencrypted vault. Okay? Here, what we do is that we encrypt, in the client side, we encrypt the vault, okay? And then we send to Lastpass the encryption key, but only with one more round of the PBK-DF2. Only one more round. So we can apply 5,000 rounds, but that will be like in the client side. But when we send the key to Lastpass, we are only sending one more round. So what enters to the Lastpass server is only one round of PBK-DF2. Supposedly, I mean, they apply another extra 100,000 rounds. But what it gets to their server, it's just one more round of PBK-DF2. So let's start with the attacks. Now we more or less understand how Lastpass work. We know what they claim. Let's try to figure it out how to jump above it. So the first one, the first scenario, first environment, is attacking the client side. Let's go for it. So as you know, there is like a master password. The master password is the one who is derived to then encrypt the vault with all your credentials. So let's attack when the user checks the remember password. Let's understand how it works, how your master password is encrypted in disk, and let's take advantage of that. So the creds are stored locally. If you remember your master password needs to be stored locally. You are not going to send that to Lastpass, of course. So depending on the browsers, as I said before, the master key password gets stored in files, in Firefox, in prefs.js, or in the rest of the browsers, they use like an SQLite database. And they use ECB or CBC, depending on the version of Lastpass you're using. Here we just can see like a table with different browsers and OSs and where those files are stored, are present. Here we can see the SQLite database, and they save, as you can see, there's username and password. The password is encrypted, and the username is clear text. And of course, you can access to this database without being root. The table, exactly table, what it is, it's called Lastpass saved logins 2. And in Firefox, as I said, it's stored in pref.js with extension.lastpass login users and extensions.lastpass.login passwords. So how it is encrypted? We want to get the master password. How it is encrypted? Basically, they are using AES 256. They use a random IV, that's correct, and the key is a SA256 of your username. Of course, your username, it's in clear text, as you could see before. So basically, and the data that we saw, that's what we need to decrypt. Basically, they are storing the key, and they are storing the encrypted blob just together. It's pretty straightforward, just decrypting it, and we will get the master password. And that's it. We get the master password, we can use it to access the vault, and access, of course, all the keys stored in the vault. Oh, yeah. So we published it, Martin did. That's the stats of his blog.
No one visits me.
No one visits him. Look at him, nothing, absolutely nothing. And then he published this. Yeah. He published it, and he got a lot of visits. So that's when we were supposed to stop this research. It was a small research only for this specific pen test. Okay, we got it, we loot everything, we won, game over. But then we published it and we saw that people was interested in Lastpass. And then is when I'm gonna change the mic to Martin.
We're gonna be doing this switching back and forth, so sorry about that, guys. All right. Yeah, this was interesting because we just did that for the pen test, right, with the 10% of the research we have at Salesforce. And it was really cool because suddenly on NetSec, it was the #1 and all that. So a lot of feedback, a lot of good feedback, bad feedback. But basically what we got from it is that the community was very interested in understanding Lastpass and what else you could do with it. So we said, okay, maybe it's worth just investing more time on it. look if there is more threats to it, and share it with the community. So the first thing, obviously, I know what you guys are thinking. Who's going to click remember password? And I asked Lastpass, and a lot of people does, because the first thing was just don't offer that option, right? And yeah, actually a lot of people does. So what was, oh yeah, I have it here. So the first thing we did was like, okay, let's do the classic, right? Let's see what we get with the cookies. But it's interesting because in Lastpass, what the cookies are going to get you is basically what Lastpass has. And what Lastpass has is supposedly not to be anything that you can use to decrypt the vault. So that was an interesting thing. So we actually had to invest a little bit more time to see if we could do something with the cookies. And what it turns out is that the vault decryption key, the vault decryption key is the key that is derived from your master password and is used to decrypt the vault. It's going to get a little bit weird, but yeah, so the vault decryption key is stored in your machine locally, and Lastpass has the decryption key. So when you send over the cookies, they send you the decryption key, you derive, well, they send you a token, let's call it, you derive an encryption key doing a SHA-256, and you decrypt your vault locally. And this is why when you restart your machine and open the browser, it automatically logs in again. You never enter your credentials. If Lastpass don't have them, they can derive the key. But this is how it actually works. So, and just to get a bigger overview, what I mentioned before, you do basically a post request to login check, and you will pass your session cookie, and it returns this parameter that is the PWDEC key. And you do a SHA-256 to it, and that will be your decryption key. And as we saw before, it was in the database, the encrypted key, you decrypt it, and you got it. Cool. Awesome. So that cookie got us that. So that was pretty cool. But we still had more challenges, right? Because what we found is that if you have two-factor authentication, it's not going to work. So we had to deal with that too. So the next step was to understand how two-factor authentication works. This is how it looks like. We never ask how many Lastpass users are here. Can you guys raise your hand just to get an idea? That will be about 5. I don't believe that, but okay, good enough. And so they support a lot of two-factor authentication methods, Google Auth, YubiKey, 2FAIR, lots of them. So the first thing we did is we looked at the network traffic, and we didn't see any trusted cookie, which was pretty interesting. So we started to tamper with the parameters, and we realized that the one that we had to remove in order to be prompted for two-factor was UUID. So UUID is actually the trusted token. So how is it generated? We wanted to understand first if maybe we could generate it. And they actually did something smart. They basically reuse the function they have to generate random passwords, the ones that, okay, generate a random password for me for this website, put it on the vault. So they just reuse that. So basically the trusted token is 32 characters. It's basically a password. And it's generated at installation time from the plugin. And so where is it stored? It's stored in plain text. For Firefox, again, it's an edge case. It's stored in lp.suid. And for the rest of the browsers, it's again in a local, in this case, it's in local storage. Now, the thing is, why are we telling you all this? In reality, there is some problems with this design, right? Local storage, there is no browser that encrypts it, and lp.suid is not encrypted either. The same token is used for all the browser users. So if you have your corporate account and you have your personal account in Lastpass, something we do, you will have the same trusted token. That means that there is a fixed token till the plugin is reinstalled. And that's had a lot of consequences, because even if you untrust that browser, say because whatever, you thought it was compromised or whatever, has no real effect, because it's still going to be that token that is going to be sent once you actually activate it again. In fact, if you generate a new QR code because your 2FA was compromised, it's still going to be the same. That says actually that it's token fixation. An attacker could set it for you before you activate it, and when the victim activates it, it's going to send the one set by the attacker. But that's not really interesting. The interesting thing is we can proactively steal the trusted token. Imagine we compromise a machine, we get that token, the victim realizes it and says, okay, you should have activated 2FA. Okay, I'm going to do that now. Doesn't matter. We already have the token. This is the problem of not using trusted cookies and do this kind of design that they came up with. Cool. So awesome. So we know how to get credentials. We know how to use the cookies to the vault. We know how to do two-factor authentication. But we still have the problem that you can only use the cookies if there is an active session. If the user logs out, that cookie is not valid anymore, so you can't retrieve the key to the decryption key to decrypt the vault key that is encrypted in your machine. So we wanted basically to find the silver bullet, something that will allow us to, in the client side, to be able to decrypt the vault, to get the encryption key and decrypt the vault. No matter if you don't have an active session, no matter if you don't have 2FA, no matter if the user didn't steal stored the credentials. Awesome. So we saw that, right? Account recovery. And the first thing was, how is that even possible? Because if Lastpass doesn't have my encryption key, I forgot my password, I don't have my encryption key, how are you going to recover the vault? So, and it's actually as easy as 1, 2, 3. First thing you do, you go to lastpass.com/recover and you enter your email. And when you do that, you will get a unique link. That's pretty straightforward, basically how everyone does it. You click on that link and it redirects you to this really nice page with a big red button that says press to recover. We were like, okay, can't be that easy. So we clicked on it and it was that easy. Suddenly the account was recovered. We have full unrestricted access to the vault, to our vault. And we could set a new password, but we didn't have to, which we thought is funny, because why would you recover your account? It's because you forgot your password. So you should set a new password. But yeah, that was interesting. And we were never prompted for 2FA. So we really wanted to understand how this works, because I never enter my master password. I never do anything like that. And I still could have full access to my vault. And this is how it looks. From the moment you click the link, the unique link on the email, you basically get this request that returns a 302. The 302 redirects you to a URL that contains 4 parameters that we will talk about later, but it's basically time hash user and username. And then we will, and user hash. And then you get to that really nice page with the red button, and when you click on it, you do a post request to otp.php. We saw only one parameter that is hash, and that returns the interesting parameter that is rand key. Okay, so let's dive into it. First thing we wanted to see is, I don't want to need access to the victim's email, right? Can I generate a URL, that 302 URL? So we looked at the parameters. Turns out time is the timestamp when the recovery was initiated, basically when you put your email and clicked. The time hash is a salted hash of that timestamp. Username is self-explanatory, and so is a username hash. Cool, so what was the challenges here? So we needed a valid timestamp, right? That was not easy because you actually have to hash it as well. So not only do you have to get the right one, but you have to hash it as well. So, and for that, we needed the salt. So we said, okay, let's start our own account recovery and reuse our hashes on the victim's URL. And it actually worked, which tells us a couple things. The same salt is used for all users. Basically, I started my own recovery, and I basically took that timestamp with that timestamp hash, pasted it in the victim's URL, and it worked. So I already had a valid timestamp, which was cool. Another thing that was interesting is that the link doesn't truly expire. The only thing that happens is that the timestamp is validated against the timestamp hash. But it's not that they have server-side something like, okay, it has been more than 2 hours for this. And there was no need to start an account recovery. So there was not like, oh, someone initiated account recovery, we have that on the server side, we know about it. No, if you have a valid link, that's all you need. But we still needed the salt because we had the timestamp, we had this timestamp hash, we had the username, but we couldn't hash the username of the victim. So that was the problem. So basically the secret, what we were missing, is the global salt. And it's just interesting that salts are not meant to be secret, they are only need to be random and secure. So we moved on. We moved on to the query from when you click, to the request from when you click press to recover. And that only had one parameter, which is the hash. So we looked into it, we used the Python script, and we saw that it was a derived disabled one-time password. And it turns out in Lastpass there is 2 types of one-time password. One of them is the one you basically are aware of, which is the one you basically print out and use to log in an untrusted machine. It's only valid for once. But then they have the disabled one-time password. And from now on, we're going to call it the OTP because it's going to get a little confusing. Okay, what is a DOTP? It's used to recover your vault, which in reality means for authentication. And it's not yet the vault encryption key. Of course, if not, that will be super easy. But the most important thing here, with respect to the other attacks that we presented, is that it's set there by default. So when you install the plugin, you log in, it's set there by default locally, okay? Cool, so, and where is it stored and how? Again, it's in plain text, in Firefox, it's in the SHA-256 of your username, _FFF_SOTP. And in the rest of the browsers, again, it's in a database that no root needed, they're in clear text. Awesome. So how is actually the request forged? So we looked at the DOM, we looked at the JavaScript of when you click the button, and basically it gets injected by the plugin into the DOM in Lastpass, and that's how it's sent when you click the button. Awesome. So how do we get from the disabled one-time password stored locally in your machine in clear text to the vault, which is what we really want to know? So basically the plugin asks the local storage, okay, give me the disabled one-time password that you have. Then what it does is a SHA-256 of the username plus the binary version of the disabled one-time password. This is kind of like a layman's HMAC. And it uses that token as an authentication hash. So it will send that token together with your username, and then you get a valid session. And together with that valid session, you get another parameter that is called the RAND key. And the next request we see is it retrieves all the encrypted vault from Lastpass, and you get it locally as well. Cool. So the question here is, what is RAND key? So now that we got RAND key from Lastpass, it's not yet the vault encryption key, but it's the vault encryption key encrypted. So how do we decrypt it? So it's actually encrypted in AES-256 CBC, the ID is random, and the key, basically the secret to decrypt your vault key that Lastpass has, is the disabled one-time password. So you just do a SHA-256 of that, and you can decrypt it. So again, what is a disabled one-time password? It's actually a master password on steroids, because you can use it to authenticate. You can use it to obtain the vault key, encrypted, but you can use it to decrypt it as well. And in addition, it bypasses IP restrictions from the test we did some time ago. It bypasses 2FA, and it's stored locally by default, which is the real cool thing here. And the vault, turns out we have it locally as well. And it's basically in this format, again, in Firefox, it's in a specific file. For the rest of the browsers, it's SQLite. And it's basically encoded in base 64, the encrypted vault. So that's awesome, because now we are able to get encryption keys in all cases, no matter if you have active sessions, master passwords, whatever. It's just there by default, and we can use it. We know how to retrieve it. We know how to derive the encryption key, and we know how to decrypt it. So
basically, we're fucked.
So that is really cool. I told you not to swear, man. So what are the conclusions? We know how to get the credentials and derive them from the vault. And we know how to use the disabled one-time passwords to obtain and decrypt the vault key. And we know where the encrypted vault is, we understand the format, and we know how to decrypt it. So we can print all the passwords out. So that was really cool. Awesome. And actually, I'm going to leave Alberto. So we told you a lot of stuff, and we thought, okay, if we have all this, we want to contribute back to the community, and actually, especially to pen testers. And so we wrote a Metasploit plugin, a post-exploitation Metasploit. No. I got that. I'm not going to tell you my password. You work for the red team. Forget about it. Okay.
The other way around. Come on. Okay, so we wrote a plugin, a post-exploitation plugin for Metasploit. So it will be very easy for anybody to use it to, when they're doing a pen test, they're doing a red team exercise, just access to the credentials using all the techniques we spoke about before to retrieve the credentials from the vault.
Slide. Go back to the slides, because we have basically all the features that you click there,
yeah.
Click play, just to have an overview of what the demo
It basically applies all the research we did, all what we told you about before, and it basically steals and decrypts the credentials that you have in your vault. It steals the 2FA token. Even if the user doesn't have it activated, we proactively steal that 2FA token. So if the user in the future activates it, we are still in. It steals and derives the encryption key. So you will not only get the actual plaintext creds, but the decryption key for the vault. It decrypts the vault, of course, prints all the passwords that you have in the vault, and it supports all those different OSs, Windows, Mac, Unix, and those for browsers. We are finishing the integration with Internet Explorer to steal Internet Explorer Vault 2, and of course we can use it from Metasploit, and it's multi-user.
If you want to play with it, we just I just push it to my repository. We put the URL there. There is some to-dos bugs. It was yesterday night. We are with jet lag, but it should be good to go to do some tests.
Yeah. So basically, this is the victim machine, and this is Donald Trump. I don't know if you know him, but it's a nice guy. We live in San Francisco, and it's every day in the news. So here we have already some session open. I mean, we're not gonna get in how do you get access to a machine. That this is a post-exploitation model. That's something up to you.
So basically, what we have here is that the victim's machine, which is Donald Trump's, he has two accounts, right? He has his own personal account, but he also has an enterprise Lastpass account. And in addition, he's nice enough to let his girlfriend use the machine. So there is a second Windows account with the girlfriend's Lastpass account. So basically, we have 2 Windows accounts and 3 Lastpass accounts. One of them is enterprise. Okay.
So basically, the only thing we need to set is the session, the Meterpreter session we want to run this module against, and just say run. It's very, very straightforward.
Is that the time where we cross the fingers? Or?
Yeah, more or less. On my toes, fingers crossed.
The Wi-Fi is not very reliable, so if it doesn't work, it's not our fault. Okay? All right, so yeah, basically it's extracting everything we told you about. This is a nice error we like to print, but it should work. I was getting this error yesterday, but it doesn't really do anything bad, or I hope so. Come on, 3, 2, 1, boom.
Oh.
Yeah, it's gonna work.
Oh.
There you go, awesome.
Okay, vamos a hacer menos.
It's anyway not gonna make a difference, so.
Okay.
Yeah.
Here we go.
There. Sorry, it's a little messy because of the...
Yeah, the size. But basically, it says, what account are you extracting the credentials from? Yeah.
So basically, you have here, right? You have what we give you is basically the Windows account, as you can see, is from Donald Trump. We give you the username.
Yeah, the username and the password. Here in this case, because this is a corporate account, he didn't store the master password. Okay, so we couldn't get the master password, but we could get the actual 2FA and the key, the decryption key that is here. We have another account.
We did that, so basically, because we couldn't derive it from the credentials, because he was using an enterprise account and he was not allowed to store the master password. In this case, what we used was the cookie to get it, because he had an active session.
Exactly. Here in this other one, this is the personal account from Donald Trump, and we were able to get the password because he clicked on remember my password. So we decrypted, and the same thing. As you can see, the 2FA is the same for both accounts. Here on the other side is a different user. That's the girlfriend of Donald Trump. And we couldn't get the password either, but we were able to get 2FA and decryption key. And here, down here...
Case, yeah, the decryption key, we got it because in this case we used the disabled
one-time password.
Turns out she didn't have an active account, so our plugin basically, it iterates. First it tries to look for the master password. If it's there, then nice, because everything happens locally. If not, we try to use a cookie, and if not, we always rely on the disabled one-time password.
Yeah, and here you can see for every user, we can see the actual URL, the username, and the decrypted password. Like the same. That's username and password is here, okay? We did that for the personal Trump's account, the corporate Trump's account.
The other one was the Trump's baby's, the girlfriend.
Yeah. And here we can see all the information for the different accounts. So it worked. Thanks God.
I told you the Wi-Fi is not reliable and still worked.
It is very useful in the exercise, the red team exercise, because as I said, normally you don't have a lot of time. You can you can say, okay, Alberto, you can install a keylogger and just get the password. Okay, you can get maybe 1 credential, 2 credentials. The good thing about this is that you get into a machine, you run this plugin, and you get everything right away. Okay, that's something very useful when you're doing a red team exercise, because normally the blue team is there looking at you, trying to get to. So, yeah.
Awesome.
Let's do this?
Yeah. Okay, my turn again. So actually, let me go back to this one. So what we are going to do now is, let's move on from the client-side attacks, okay? So now what we want to see is, yeah, I don't want you close to me, man. Okay. So now we moved on from the client side. We show you some different attacks. We show you the module. So now it's time to move on. So now we wanted to understand what are the risks if Lastpass will be the attacker, which is not the case. But truth is, Dalen, they had a breach a couple months ago, so the attacker can be on Lastpass side. And in addition, we also have other things like NSA or whatever that could try to force Lastpass to give some of your data. So we really wanted to understand what is it that with the information that is on Lastpass servers you can do, which is in the end the goal of this business, that they can't do anything, and if there are some attacks. Cool. So it's time to get paranoid, okay? We are Lastpass, so let's get paranoid here. And we brought here our hats. This is very important when you want to get professionally paranoid, and we got some for you too. If you want to, we can put them there. But this is paranoid mode, okay? All right. Awesome. Okay. Paranoid mode on. We are Lastpass on Lastpass servers. We are some hackers, something like that. Cool. Does it look good on me? Yeah. No. Okay. Next. Okay, so the first thing we wanted to see is like, okay, let's look at what does Lastpass see in reality. Alberto already mentioned that in order to derive your encryption key, your vault key, from your Tixcro credentials, they use a PBKDF2 with 5,000 rounds, right? So you get your encryption key. And then what they only do apply an extra round to your encryption key in order to authenticate. So the first thing we realized was there is no really PBKDF2 protection. It is locally for your cleartext credentials, but not for your encryption key against Lastpass. So this is something to keep in mind. So another thing we saw is that the Lastpass also has your vault key encrypted in a couple of different ways. One of them we talked about, which was the disable one-time password, remember? And the disable one-time password is 32 characters, so we are back to 256 bits. But if you use the regular one-time passwords, that's only 16 bytes. So it's no big deal, but one of the things we found is like, first, you don't get the PBKDF2 protection for your encryption key, and now they have your encryption key encrypted, but with a key that is not really 256-bit, because it uses a username that they already know, and there is no PBKDF2, so there is no brute force protection. So this is something to keep in mind as well. Paranoid mode on, okay? Again. And then we have the encrypted vault, which we'll have a look at it, okay? So this is an encrypted vault, and it doesn't look very encrypted from that picture, right? We see a lot of more encoding, we see some JavaScript, and there is some data missing, but don't worry, we are not going to say it's not encrypted, because then that's all we will have said. So the encrypted vault actually turns out that your URLs, icons, and metadata is not really encrypted, which could be fine or not, because I don't know if you're the kind of guy that registers in porn sites or some other stuff, or think about it like if you are registered in some forums that are politically incorrect or things like that, you know. Basically, you get no privacy because Lastpass can see your URLs. They are encoded, not encrypted. And another thing we realized was that when you reset your password, imagine on Twitter you want to reset your password. Usually the way it works is you click on reset your password and you get a unique link on your email. You clicked on it, you get redirected and prompted for new passwords. And then Basically, what you will do, you enter your new password, Lastpass detects it and suggests, hey, you want me to update your password. But that URL is taken, and now that URL, which is the unique URL to reset your password, is on Lastpass side. Now, if the webmaster did not a good job and did not expire that link, or the link just never expires, that is bad because they could reset. And when I mean they, I don't mean Lastpass. I want to make that clear. We work with them. They are awesome. So when I mean they, even though we're talking Lastpass side, I mean hackers that attempt to be there, or NSA, or, well, I shouldn't say anything bad about NSA either, I guess. Okay, so you know what I mean. And cool, so another thing we found was that actually your passwords are encrypted with ECB. Remember, like, your vault is really just, it encrypts really the password itself. It's not an encrypted chunk of something that you can't understand anything. It's more metadata with encrypted values. So, and this is not the best thing because it will leak some information about password length, which actually happens in CBC too, but yeah, something to point out. But especially it will leak the passwords that are identical because of how ECB works. And you say, well, that's not a big deal because they still don't know my password. But one of the things we thought is, think about all those dumps of passwords that happen because Adobe, so 10 million passwords. Your URL is encoded, so they know where you're registered. Now, they could know that you are registered in that site that leaked the clear text passwords or that someone decrypted. So I go there and I look at your clear text password. I go to your vault and I see you are registered there, and I see the ciphertext of your encrypted password. Now, if I see that same ciphertext in other accounts, I know it's the same password, and I know where you are registered because I know the URLs. So this is why this is not the best thing. And then it leaks also information about similar passwords. If you have like hello123, hello1234, hello1235, ECB can leak some of that information. And this is interesting because this is the encrypted vault, but an XML version. We were tampering with the APIs, and suddenly we got this, which is not used by any plugin or anything, but it was cool to see it this way, and we were a little bit more paranoid. And here comes the cool thing. One of the things we saw was, sorry, you don't see very clear, but it's this parameter for every single account that is custom_GS. And we said that it has JavaScript. Again, this is the encrypted vault. This is clear text JavaScript on your encrypted vault. So we wondered, like, okay, what is exactly this for, right? And it turns out that Lastpass has a legit reason to have that, is it can't always guess where basically the input nodes are basically to inject your credentials, right? I go to facebook.com and it always knows where to put the username and the password. But there is a lot of bad webmasters out there, or they use Flash or things like that. So Lastpass may have a hard time to try to guess where they are. So they inject JavaScript in your vault to find those for you. And custom.js is the one that has that. So, but what are we really saying here is that Lastpass or any attacker compromising their servers can add clear text credentials to your vault. What did I say? Can add clear text credentials? No, sorry. Can add a JavaScript payloads to your vault for every single account, and that JavaScript will run in the domain's context. For example, if they inject JavaScript to my Facebook account, as soon as I get to Facebook, that JavaScript will run, which again is in clear text in my encrypted vault and in Lastpass server's hands. And it's also executed on every single page load in that domain, not just on the login page. So what is actually custom.js for an attacker? It's the JavaScript payloads are not encrypted. The plugin does no validation. They just do create a script node, inject this, close the script node. That's all. Victim does not notice anything strange. You can do payloads and nothing is going to happen. It just runs in the background, right? It's JavaScript. The JS payload executes on every page load, as I mentioned before. The cool thing is because the URLs, again, are not encrypted, and this is metadata that is not encrypted either, just the values, someone on Lastpass can add new accounts to our vault with their JS payload. Say you want to steal my emails, and I don't have my emails credentials on Lastpass because I just know the password. So, but they could inject a new account that is Gmail, add the payload, and it's still going to run. So that is something to keep in mind. But the best thing of all is that Lastpass, again, for legit reasons, offers two variables that actually contain the clear text username and password, which is lpcurUser and lpcurPass. So I don't even have to wait with my payload to come up where, okay, where is this page going to put the credentials? I have to wait till he writes them, or oh, okay, he was already logged in, so he's never going to enter it. I can just use these two variables and get clear text credentials. And we did. We basically were on the network, and we acted as if we would be Lastpass, right? And we actually put a payload just to see if it will work, and it will work. As you can see here, we only alert the clear text passwords, but basically what the plugin will do is inject those payloads in the DOM, and that's it. No validation, no nothing. So we thought, okay, let's play a game here. And so you basically understand the use case. We are NSA versus Lastpass, okay? So you want to play NSA or Lastpass?
Okay, I'm going to do NSA.
Okay, so I guess I do Lastpass, but I guess we like to put things so. Okay, I'm going to be Lastpass now, okay?
Awesome.
So we want to make it clear.
You're very Lastpass now.
Very Lastpass.
So yeah, I'm NSA here. Hey, Joe, I need access to Donald Trump email.
Sorry, man, I can't decrypt any vault. I don't have the encryption key.
Come on, I know that you can see if he has a Gmail account.
Yes, but I just told you I can't decrypt anything anyway.
Wait, we can misuse the custom GS, and we can append this payload that I'm giving to you.
You know, I'm not comfortable doing that. This is my business. Sorry.
Yeah, you know, you don't have any choice. I am NSA.
Okay, cool. But we checked, and there is no Gmail account there in the vault. I'm sorry, man. I would really do it. Don't shut down my business, but you know, there is no account. I'm sorry.
Don't worry, I have an option here we can work around. Just like inject a new account to the vault and include this other payload and create this Gmail payload for him. That's it.
Oh, shit. All right, so I guess we have permission now to take the paranoid hats off, right? Yeah. Awesome. Okay. Cool. And I think now, yeah, awesome.
This is like this at the end. So attacks from the outside. What happens if we are not in the client? We are not in the server side. We are just an outsider. So do you remember like Firefox prefs.js? You know that people uses this when they have some troubleshooting. They upload all the configuration of his Firefox because they got some adware or something like that, and they really want to remove the adware. So you just send the configuration, including prefs.js, to the internet. So basically, you can just use a Google Doc and search for that file.
That's our very advanced hacking techniques.
Google Docs. So yeah, it's maybe not a good idea if you want to search your encrypted password with your key to decrypt it.
That's basically, we found it in forums, we found it in pasting and things like that. Basically, some people is uploading their credentials with the key to decrypt them. So.
Yeah, not a good idea. Don't do that, guys. And last, hardening Lastpass. So we want to be very clear here. We have been like back and forward with Lastpass. The team that they have that take care of security is awesome. They did a tremendous job. Actually, most of the things that we sent to them, that we reported to them, were fixed within 72 hours. And of course, these same issues may happen in other password managers. We are not saying that Lastpass is a wrong decision. Actually, we use Lastpass, both of us. That's why we use some time on this. We care about our passwords. And this is a list of the issues that we reported to them, and they fixed it. Now they warning you when you try to store your password, your master password. The recover URL can't be forged anymore. They changed it. Recover process needs to be initiated now. You remember that we were saying that we were able to bypass the initiation process? That's not a thing anymore. They rolled out recently an SMS functionality to recover your account. So that's a proper 2FA. Firefox does no longer store creds in prefs.js. Oh, that was sad. I was crying the whole day when I realized about it. And all users affected by Google Docs were contacted by Lastpass. That's a good thing. And there's a lot of more alerts regarding sensitive actions. And we have recommendations for you, and we have recommendations for Lastpass. These are the recommendations for you. Download the binary version of the plugin. If you can, you just do that. Install the binary version, you will bypass some of those problems we saw before. Do not store your master password, please. You say, no, I don't do that, but yeah. I've been in, while I was working in the red team, I've been in hundreds, thousands of machines. People do store the master password. Audit your vault for malicious GS. This is kind of complicated, but this is up to you. Don't use password reminders. Activate 2FA. We saw that it's not very useful using 2FA, but at least we can add some extra layer of security. Prompt for master passwords to reveal password. That's like an advanced option that you can activate. And it's painful. You can say that it loses the actual way of like the easiness of using Lastpass, but you can do that. Add countries restrictions. I'm not going to be in China. If somebody like logs in my Lastpass account from China, that will trigger some alerts. You have that option. There's that feature to do this kind of restrictions. Randomize. I've changed the number of iterations for PBK DF2 and disallow Tor logins. And for Lastpass, encrypt the entire vault in one chunk. Just do that. Don't do that weird thing, encrypting only some specific chunks within the actual vault. Don't use ECB anymore. Let's move on. Use authenticated encryption. Get rid of custom JS. We saw that that's a big deal. I really don't want anybody to be injecting JS like JavaScript in my DOM in any website I visit. That's not good. Use PBK DF2 between the client and Lastpass also. Instead of using just one more round, just do that extra step. Use CertPNN. Embrace open source. That will be very useful because we said that it was JavaScript minimized. It's a pain in the ass, actually, to get through all of it. And what do you think about this one, Martin?
They should adopt a retroactive law, cash-rewarded bounty program. T-shirt-based programs are okay.
I have another one.
It will be just pretty cool if they will do that.
He gets a lot of girls with that T-shirt, actually.
Yeah, for sure.
And this was it. We're open to any question. Thank you very much.
Thank you very much for attending.